All right, in this lesson we're going to do the chain rule. So we did the power rule and the product and the quotient. The third one, and it's actually quite simple when you understand how it works, is the chain rule. What the chain rule does is it's sort of like a modified power rule. So we've looked at power rule questions where if I gave you something like y equals 4x cubed, we could do the power rule on it, so our derivative would be 12x squared. So basic power rule, pretty simple. What the chain rule does is it sort of mixes that with when we have brackets. So I like to think of the bracket, like when you think of the word chain rule, I like to think of it as more of a bracket rule, and that's probably an easier way to sort of approach it. So when you get a question that looks something like this, we don't know how to do that derivative yet, so we got a square root. So when we did limits, we did square roots as rationalizing and try to get that root to cancel out and things like that. But there's not really a simple power rule type formula that would work from the limits. So what we treat these things as, we try to think of them as two separate functions. So if I would have given you one equation, actually let's use letters. So if I would have given you f of x as being square root of x, and if I'd have given you g of x as being 2x cubed plus 3, you can see that the question now is just basically combining those two functions together. So if I told you to do f of g as a composite, that would give us the question that we want. So the way the chain rule works, it's sort of like doing composites and breaking these things into two parts. So we can do the derivatives of both of these things the way they are. So the derivative of root x is pretty simple because we can do power rule on that. Derivative of g of x is pretty simple. That's a power rule. It's what do we do when we put them together. So what we try to do is we try to think of these as being a composite and do the two derivatives separately. And then we put those two together to make. So the way the chain rule is written is we sort of use, there's different ways of writing it, but if we look at let me just give you a different example, that'll be a little bit easier. So if I gave you something like y equals square root of x plus 5, right? So what we're basically saying is let's treat this as y equals square root of u. And that's what this notation's using. They're just using u's instead of f's and g's, but it doesn't really matter. So that we could do. We could do the derivative of this equation. The problem is by changing the variable, we're now doing the derivative of y with respect to u. So this u to the half, we do that derivative, it would be 1/2 u to the negative 1/2. So that works, but that doesn't give us dy dx. So if we call whatever's on the inside the u value, now the derivative of u with respect to x is 1. So if we're looking for dy dx, you can see the way the formula works is we would go dy du times du dx. Because then those u's, you can see just the way the formula works, those would kind of cancel out in the end and we'd get what we want. So if you put these two answers together, dy du is 1/2 u to the negative 1/2. Du dx was 1 in this case. That would be our final derivative. So the only thing that we would do differently is we don't want u on there. We just resubstitute. So take our u value, plug that back in. So our final answer should be 1/2 to the u, which was x plus 5, to the negative 1/2. And that's it. So the chain rule works pretty good. I think where people struggle is the notation, the du's and the dx's. So what I'm going to show you is just a little bit better way to do it. So if you look at sort of using the prime notation, you can see we have the derivative of a function inside of a function. So that's what that's showing you. That's the f of g kind of notation. So if you look at the way the formula is here, it says do the derivative of the outside function, which is basically just saying the brackets. So if I give you another example, let's suppose we have 3x plus 5 to the 4th. The derivative of the outside part, the f function, is just the bracket part. So do the derivative of that. So bring the 4 down, drop it to a 3. So that's just basically our power rule. Leave the inside the same. And then the second part of the formula is times it by the derivative of g, which in this case, the derivative of the inside would be 3. And we could simplify this a little bit to make it 12 times 3x plus 5 cubed. Okay, so that's the way I would approach these. And a simpler formula yet is it's basically just a modified power rule. So remember, when we had the power rule, we bring the n number down to the front, drop your power by 1. So you can see what this is. It's basically just doing the power rule on the outside, bring the n down, drop it to the n minus 1. But whatever's inside the brackets is a function, so we have to times it by the derivative of that function. And that's probably the simplest way to do these questions. So let's do a few examples and you'll see it's quite simple. So the trick with the chain rule is you want to rewrite every question, if you can, to be a question that has brackets to the power of something. So in this case, change the square root to be the power of a half. Now our derivative is pretty easy. Apply the power rule to the power part, so bring the half down, drop it to negative half. The function on the inside, the g on the inside, doesn't change. We just keep it as 2x plus 3. And then the last part is times it by that derivative of whatever's inside the brackets, which in this case is 2. Bring that 2 to the front so we can simplify it to be just 1, 2x plus 3 to the negative half. And because these are square roots, if we really wanted to, we could switch it back to a square root. And the negative half would just mean it goes on the bottom of the fraction. So either of those two notations that would be correct for your final answer. So let's try a couple more. So this next one is x squared minus 2 to the 4th. So we would do the same thing. Bring the 4 down in front, drop our power to a 3. So that should be the easy part. It's just like regular power rule, except you just treat whatever's on the brackets as your power. And then in this case, derivative of the inside is 2x. Bring that to the front. We could simplify it as 8x times x squared minus 2 cubed. If we would have FOILed out this original question, we could have used the power rule directly, but it would have been pretty long and complicated FOILing out procedure, and that derivative would be exactly what we just got for our answer if it was FOILed out. So what's nice with the chain rule is it sort of gives you the final simplified factored version of your derivatives, which is more preferable and more compact than writing the FOILed out expanded version. Okay, here's another one. Looks a little bit more complicated, but again, if you can write this as a single chain rule, it is definitely a lot easier to do these questions. So what I would do with this one is bring the cube root to the top, and so it's on the bottom of the fraction, but that doesn't matter. We can just rewrite it as 1 minus x to the 4th. Cube root be a 1/3, but it's on the bottom of the fraction, so that would make it negative 1/3. Now it's just a regular chain rule question. So to do our derivative, bring the negative 1/3 down in front. That would drop our powers to negative 4/3. And the derivative of the inside of the brackets, bring the 4 down to be negative 4x cubed. And again, let's bring that to the front. So if we simplify that, the two negatives would cancel. We'd get 4/3 x cubed times our brackets. And we can stop there. That's good enough. So you don't need to expand these too much further. You don't need to try to change them back to square roots or anything like that. Just simplify your front numbers and that's it. So a lot of people find the chain rule pretty simple because it's really just the power, right, doing the derivative of the brackets. Okay, here is another one. Do the same thing. Let's rewrite it as a single chain rule. So bring the square root to the top. So that would give us 4 times 9 minus x squared to the negative 1/2, right? Make it a power. The 4 in front doesn't matter because it's just a coefficient, so do it just like we did with the regular power rule. Oops, this is the derivative, or this is still the original question. So now the derivative would be bring the negative half down in front, so negative half times 4 would give us negative 2. Keep our brackets the same, drop our power by 1, which would go to negative 3/2. And then in this case, the derivative of the inside is negative 2x. And remember, we're multiplying those, so let's bring that to the front to make it a little bit easier. So negative 2 times negative 2 gives us positive 4, and the rest would stay the same. And that's our final derivative for that one. So I have one more. So this one looks a little complicated, but it's pretty simple. We're going to do more of these in the next lesson, but this one still, even though it looks weird, it's still basically a chain rule. The only difference is we have 2 square roots. So basically all I would do is change them both to halves, get rid of the roots, make them halves, so that's pretty straightforward. Now we just follow our regular chain rule steps, so bring the half down, drop your brackets to -1/2, keep the inside brackets the same, and now we multiply by the derivative of the inside, so derivative of 1 is 0, derivative of x to the half would be 1/2 x to the -1/2. So it works out the exact same, just a basic chain rule question. So now again, bring that to the front, so the half times a half would be 1/4, and everything else stays the same. And we can stop there, that's totally acceptable. Or if we wanted to switch them back to square roots, let's just see what that would look like. So the 1/4 would put a 4 on the bottom, x to the -1/2 would be a square root on the bottom, and then it'd be the whole original question on the bottom again as a square root. So again, you don't need to do that. You could stop just where the fractions are. That's totally acceptable. And that's it. So the chain rule, you can see, is pretty basic. So with what we've covered so far, I would say power rule is the best. It's the easiest. If we had a product rule question, we saw that it was almost better to do product as a power, just FOIL it out and do power rule. So that kind of skipped that one. Now I would say what we just learned is probably the next easiest. A basic chain rule is just basically a modified version of the power rule anyway, so that was pretty easy. And then our only other option that we've learned so far is our quotient rule. And a quotient rule is basically any simple dividing question. So with these chain rules, even though we looked at some that had dividing, we just changed them from a quotient to a chain. So if you can always simplify it to the one above the list, it's probably a good idea. Just like the product, we simplify it to a power rule. That would be easier. If you could get a quotient and simplify it to a chain, that's going to be easier. So that's going to be sort of the progression we go through these questions. Try to do the power, then try to do the chain, and then do the quotient last if there's nothing else that'll work. And our next lesson now is what happens. We start mixing these together. So we're going to have a power and a chain, and then inside of that chain there's a product or something like that. So that'll be our next lesson, but we'll stop here for today.